some logarithmic equations. We're going to look at, we've already solved some, but the ones that we solved had the same log on both sides, or we did look at a few that had different logs and we used our calculator. But let's look at how to solve this equation right here. Now, please, please, please do not add the 5 and the 2. Okay, again, multiplication comes before addition and subtraction. So it's 2 times the natural log of x before it's 5 plus 2. Okay, so we are going to start by subtracting the 5 from both sides. So we've got 2 natural log of x is equal to negative 1. Then we divide by 2 on both sides. So we've got the natural log of x is equal to negative 1/2. Okay, so in our last set of problems, the variable was stuck in the exponent, so we put it in logarithmic form to get it out. Now our variable is stuck inside the logarithm, so what do you think we're going to do with it? Put it in exponential form. So the base of the natural log is e, so when we write this in exponential form, it's e to the negative 1/2 is equal to x. And that's the exact answer. Okay, that's the exact answer. But you can, of course, use your calculator to evaluate e to the negative 1/2. And your approximate answer is 0.607. So again, we can check it. 5 plus 2, natural log of the answer should give us 4. And it does. All right, let's look at B. Okay, let's look at B. Alex it up. Divide both sides by 2. Okay, so we get log base 5 of 3x is equal to 2. Then we write it in exponential form, so 5 squared is equal to 3x. Then we're going to divide by 3, so we've got 5 squared is 25. 25 divided by 3 is equal to x. You got to be careful if you're checking this one because you have to use change of base. So I would do the log part first. Log of 3 times 25 over 3 divided by the log of 5. Then multiply it by 2. Okay, so that's how to check that one. Now, let's look at example C. A whole bunch of logarithms right there. Whole bunch of logarithms. So here's where our properties are going to come into play. They're going to help us out here. We need to combine those 2 logarithms that are on the left side. We need to put those together first. So which property are we going to use? What do we do with 3x plus 14 and 5? What do we do with that? Divide. Okay? Now what do we do? Do we divide by log? What happened Friday when we had the same log on both sides? They cancel. Essentially, we just set what's in them equal to each other. Okay, so if we have the same log on both sides, then we just set them equal to each other, and then we can solve. So we multiply by 5. So that gives us 3x plus 14 is equal to 10x, and then 14 is equal to 7x when we subtract the 3x from both sides, and then x is equal to 2. And that's the final answer. Okay? We could plug it back in and we could check. Now, if, let's just say, for example, this right side had not been the log base 6. Suppose the right side had just been 2x. Now, well, let's say it was just 2. If it was just 2, hey, what's that? This is